Welcome, this is Professor Bright, and we're going to go through sequences today in this series of videos. And so in the videos, I encourage you, if you've never watched a video to learn, certainly I recommend first thing is print out the notes. Print out notes. And again, these are available to you. They are linked in the Google document for along with these videos. But I find printing out the notes is useful for students so that they have the materials later on, and it actually speeds up the note-taking process. And then also make sure to, take notes. Okay, so pretty much whatever I write down on the screen should be in your notes, and then also any comments I make, because I do ad lib a little bit, make sure to get those in your notes as needed as well. Okay. Beyond that, since these videos are going to be on YouTube, make sure to pause me if you need to, rewind, and in most cases, my students tell me actually they like to watch me on about 2 speed because are just used to that. So if you need to speed me up, feel free to do so, and then captioning is available as well. Okay. In this first video, though, we are going to look at more just reviewing sequences, but overall what we want to do is make sure to remember what a sequence is, talk about the limit of a sequence, because that's where calculus comes in, and then talk about monotonicity and boundedness, and then apply what I affectionately call MST, the monotonic sequence theorem, to show that something is, to show a convergence of a sequence. And that one, I am going to recommend you watch that a few different times because that is a major part of this section of the course. Okay. In terms of other announcements, again, this is our first crack with online learning, so if you have questions, feel free to reach out. But without further ado, let's talk about sequences. All it is a list of numbers written in a definite order. And so here I just have a generic A1, A2, A3, A4, etc. It could go on forever, maybe, in which case it would be infinite. Could stop at term n, in which case it would be finite. Okay. And in general, we talk about the nth term as the nth term. When we look at infinite sequences, there's a little bit of notation that accompanies it. Sometimes, generally we enclose a sequence in curly brackets. I believe they are formally called braces. And when we're talking about an infinite sequence, sometimes mathematicians are lazy and they don't include like n is equal to 1 to 100 if it is infinite. They would just kind of leave that off, or they might specify it as you see here. Okay, and then again, sequences, there may be a pattern to them, there might not be. That is certainly okay. Now, when we see sequences, they could appear in a few different forms. You could see them in just sequence representation form, or what we kind of call closed form. Closed form is more like a formula or some way to formally describe the sequence. Otherwise, from the sequence representation, you might just have a collection of numbers, and you have to either try to identify a pattern or see how they generally connect. So what I want you to do right now is pause the video, and for each of these, see if you can fill in the missing spots. So for sequence AN, see if you can come up with a closed form or like a formula representation for it. BN, see if you can figure out what the sequence representation might be, so like how you would describe it informally. And then for CN, again, look for that closed form. Okay, well, I think for each of these, it could be a little bit of a different exercise in trying to solve each one of these. If we look at AN, I notice that the numerator goes from 2 to 5%. Okay, so this seems like there's no inherent pattern, but if I look among the numerators, this would be, again, like term, this is the first term, this is the second term, and then this is the third, and then this is the fourth. Okay, so maybe just kind of keeping that idea in mind, and so n would equal 1, n would equal 2, 3, 4. Okay, if I look at it from that perspective, the denominator really is n cubed. Okay, and actually I should put brackets like that. So n cubed. That seems to work. In the numerator, let's see, if I end up squaring n and then adding 1, that ends up working as well. Okay, so that you might just have to try from a little bit of trial and error. Okay, Bn, now this one's a little bit interesting. You might not immediately recognize it, but this ends up being the Fibonacci sequence, b of n minus 1. So to get the nth term, you sum the two previous terms in the sequence, and with this you also have to give the fact that you start the first two terms at 1. Okay, and so this is not necessarily a closed form. This we would call a recursive form, so we could see these pop up as well in our sequence representations. Okay, and then Cn, again, this one isn't immediately clear what it is, but the closed form representation, there's not necessarily a formula, but we would just say it's the nth decimal of pi. I was going to write it out, but let's just put the symbol. Okay, so closed form, again, is a formal way of describing the sequence, typically using a formula. The sequence representation could be an exhaustive form where we list it all out, or a recursive form. So again, that's just a little bit of review from sequences, and then as we go on, now we're going to start to look at the calculus and how that fits in with sequences.